more than one listener.
Good evening, everybody. My name is Paul Prowse. I'm a member of the Bromsgrove Astronomical Society, and I'm a teacher at Bromsgrove School.
So I've met you at Bromsgrove, I presume?
Indeed, just before Christmas.
Yeah, and were you there when I was there in person doing a talk?
Sadly not. No, I've recently moved, so I was not there the first time, but I've come to recently.
Yeah, so it's nice to have you on board tonight, Paul. So I hope you enjoy joining our panel tonight. You're welcome to join the panel any time. It's open to everybody. So come in, have a chat, and join in. So the rest of the panel tonight, Dave, what you've been up to?
Busy day at work, the usual. Come home, my wife decides to break glass on the floor, so lots of pieces out all in the kitchen, and then she has a coffin fit. In the meantime, I bought a new phone, and then it decides to lock me out of my email account. Hotmail and other accounts are available, as we always say. So basically, I've been trying to get passwords sorted, and it's locked me out for 30 days, but I think I've managed to work a way around to the back door. But other than that, quite stressful, and watching rockets get launched and watching rockets land, and hopefully we're going to have a quick chat about that.
Well, we will, but I mean, first...
Absolutely amazing.
Yeah. I mean, the one thing we all wanted to do was go and do, I think it was it last night when Mars were going to be at its closest to the Pleiades. So I did a talk, and when I went outside, it was brilliantly clear. So I did the talk, and I thought straight after I got the camera ready and everything to go do the photograph outside. And of course, by the time I finished the talk, it had totally clouded over. In fact, it was foggy. So coming off the field, so there was no chance at all. So that's. But I did manage to get a photograph a few days earlier, and I did discuss it on the BBC today about what people could go and do. So they can still see Mars pretty close to the Pleiades, so hopefully they'll get a couple of photographs coming up towards the weekend. So Andy, out there in Spain, what's going on? Anything exciting?
Not anything exciting. I mean, the highlight of my last 24 hours was the flight of SN10 last night. And I watched the coverage by NASA Spaceflight, which is a media organization. They're not affiliated with NASA. They started by covering NASA space flights. So they called themselves NASA Spaceflight, not surprisingly. And at the end of the event, after the explosion and all the problems, they just put a lovely summary up on the screen that said, SN10 achieved a soft landing. It then disposed of its excess fuel in a rather rapid fashion.
I like that. That was a good one.
It was also said, Andy, that the rocket did a backward flip as a celebration of its landing. It was just one of those. Ta-da!
And it's the first Starship to fly twice.
Exactly. Yeah.
Reusability.
Reusability.
If you're going to go,
You've got to go.
Spectacular.
So, Roger, have you been managed to get outside at all since we spoke last?
Well, I've been doing a few sequences of Mars traversing through Taurus, so I'm going to try and do a little animation of how much it moves each night in the last few nights. So, unfortunately, last night was a bit of a damp squib, but the landing and failure was the highlight. My wife and I watched it on our big projector screen, 7 foot wide, so we could see it all in its great detail.
I'm coming to your house.
Yeah, why not?
Well, that's confusing because we're coming to yours, Andy.
You're welcome anytime, Dave. Once the restrictions, I tell you what, once the restrictions are lifted and people can travel again, you're all invited over for a barbecue. How's that?
You'll regret that.
Yeah, you've regretted saying that. I hope you know we got 200,000 listeners listening tonight, and they're all coming.
He did invite everybody.
I mean, the panel. And but
that was quick, Andy.
I can say that because we do have a summer that lasts for 6 months.
Yeah.
So,
what's summer?
You know that bright yellow thing in the sky. Have you ever seen that?
I'm aware of it. I'm aware of it.
I'll draw you a diagram, Dave.
Thank you very much.
Starship exploded. Yeah.
There was that was quick. Tien in Japan said he's already booking his ticket. I just had an email in.
As long as he brings the sake with him.
Yeah,
that's it.
Oh, now we've got Russian Stefan from Moscow said, "Yeah, I'm up for it."
That's it with the vodka.
Well, guys, you'd be more than welcome.
So, Simon, what have you been up to, Simon?
I gave a talk to Wessex Astronomical Society about our Frankenscope we've got in Moncton Combe. So that was kind of fun. And it's good to, they're more of the traditional format, Astro Society. So it's great to just chat and just pass the time of day. And they had a good turnout as well, 55 or so, which for a number of the clubs that have been around in this area, that's a good turnout.
I've got a talk coming up for you relatively soon. Do you want me to do a different one and still keep Herschel to Hawkwind for live?
It's probably the best idea, because otherwise you're just going to explode, aren't you?
I can, well, what do you mean explode?
Because you're so excited about doing Herschel to Hawkwind in the museum.
Oh, yeah.
Where William's feet actually were.
Well, I think it's got to be done live, because to get the experience, it's got to be live, number one. And of course, the venue.
Shall I do my new talk for you then on the in March? Is it March or April?
No, we swapped you with Julian, so you're in May. Yeah.
Do you want me to do the new one I'm doing, Moons of the Solar System?
You did that Wilts yesterday, didn't you?
Yeah, they loved it.
Okay, well, let's do it again.
It was the first time I ever did it. Do you know, I'm going to admit this on air. The reason I did it is when I sent them an email to say about my talks, I was going to do Myth to Moon, which is one of my talks. And I put, for some reason in my head, I put Moons of the Solar System, and he emailed me about four weeks ago and said, we're still up for the Moons of the Solar System. I thought, Moons of the Solar System? So he emailed me back and he said, you know, the talk you said you'd do, so I had to write one. Anyway, it went down really well. So I've got a new talk. Are
you sure you haven't been done by Andy Burns of Wiltshire Astronomical Society? He's quite sharp.
No, it wasn't Andy. Andy's supposed to be joining us later tonight, actually. He did email me. No, it was Peter.
Pete, yeah.
Yeah, so he said, and he sent me the email I said, and I had written Moons of the Solar System. So I wrote a new talk, and they loved it. So I thought, I better write a talk there quickly. So it's all about the moons of the solar system, the more important ones, the geology of them, and all the rest of it, and you know that kind of thing. So I'll do that one instead, and we'll keep that other one till 2022, and we'll reorganise a date for then, so I can come down live. Yeah, that's no problem. So who else have we got? Daz.
We got Daz, Ron, and Paul.
Yeah, well, as like Roger and yourself, I've been imaging Mars as it crept towards the Pleiades and the Hades and all that Hyades. But as you said, the last couple of nights haven't been that brilliant. So
no.
And then, as you said, the fog last night, they really didn't have. All I had was a big orange dome from the church, which they've lit up. So that was a bit disappointing. But yeah, I watched the launch of the two launches of Starship, and the two landings. One a bit of a rud. But yes, it was. Other than that, really, the only thing I'm excited about is I've got me jab next week. So.
Yay.
Well, Ron had his, didn't you, Ron? You had yours a couple of days back. You came up to the
yesterday. Yeah, and I was. Probably within a stone's throw of you.
You probably, well, you did you go down Top Street?
Probably, can't remember. But,
yeah, because it's a shortcut through from the Ellesmere Road, so you probably did. You would have passed my front door, but I was looking for cars going past on the camera with you hanging out waving, but I didn't see you. So
no, sorry, I wasn't waving. I'm afraid.
You'd recognise him by the cello. He'd be playing his cello. Okay, I mean, Peter, we got our guest coming in.
Yeah, well, what I'll do, I'll go to another track now, so then we can let our guest in, and then we can explain to him what's going on. So we'll have a.
And we come back to Paul and Ron for a little chat afterwards, eh?
Yeah. Okay.
Okay, so Cosmo's coming in. Hello, Cosimo.
Yes. So this is the prize which you usually assign every 2 years from the European Astronomical Society, and the other years he actually goes to the best PhD thesis in astronomy. So in these years, like 2021, the European Astronomical Society actually has 3 awards: one in observational astronomy, one in new techniques, and one in theoretical astronomy, and usually are focused on the early career researcher, with basically it's a very generic description, which basically encompasses everyone which is in 10 years from their PhD.
Okay, well, Yeah, the nature of our shows is what it is. It's kind of meet the person behind the award, if you like. So meet the astronomer. So I'm going to ask you some generic questions, and then the panel will ask you a few more. So first of all, the first question I always ask is, how did your interest in astronomy start?
I think I'm an uncommon astronomer.
Yeah.
I got interested in astronomy because I was actually extremely hooked as a kid by science fiction. And I thought, okay, that sounds interesting. And then I just ended up discovering that the humanity didn't know 96% of whatever is doing the cosmos. And I thought, okay, 96%, that's going to be fantastic. I'm never going to get bored in my life. And then I thought, okay, that's it. I'm going to do that. And I had some deviation and second thoughts during actually at the beginning of the university, just before getting to university. But that's, I thought, I really like it. And then I get to like it even more, and looking at the night sky and just try to solve completely new things that was seen for the first time by any other human beings. It was absolutely amazing.
So what research do you undertake at Cardiff?
So my work is in what is called time domain astrophysics, which basically, to put that in lay terms, it basically means everything that actually changes in the night skies with some kind of appreciable time scales. It might be seconds, it might be hours, it might be months to years. So for example, what I especially do is I focus on the explosion on stellar explosions. So the kind of stellar explosion are also known by the terms of supernovae, which comes from Latin. It was actually coined by Franz Zwicky in 1938. And just because they see a new stars in the night sky, which was absolutely bright, far brighter than anything else I've seen before, and they realized it was like a nova, but it was much brighter than nova, and they called supernova. And nova comes from the Latin, means a new star, because it wasn't there before, which is the entire concept of time domain astronomy.
So are you a lecturer at Cardiff as well?
Yes, I am a lecturer at Cardiff.
So what I'm going to do, I'm going to throw this over to the group who've probably got lots of questions for you, if you don't mind answering them. But first of all, I know you mentioned the science fiction, and we always get round to science. We always start talking about astronomy and get round to science fiction on this. So what sort of science fiction really took your interest?
So I'm a huge fan of Star Wars. And I actually, in my office in Cardiff, there are a series of Lego Star Wars, which are all built over there, which I do up to increase my collection. But increasing collection means I'm going to put myself out from the office. But I also I really liked Star Trek as well. I know there are lots of people there. Oh, I'm a hard Star Trek core fan, or I'm a Star Wars. I like both of them.
Cosimo, which Star Trek do you like? The original series, The Next Generation, Voyager?
So for me, the first one was Star Trek Next Generation. Mm-hmm. And then it went up to, for a long time, it was the original series, but then I ended up watching Deep Space Nine.
Yeah.
Yes.
And I really like it because it's completely different. It's all the political background and creed and all the other things, and that it's absolutely completely at a different level.
Yeah, there's a lot of politics and deep meaning behind all the writing, I think. Yeah.
It was absolutely different from all the other Star Trek series.
Yeah, funny enough, just before I came up to start preparing for the show tonight, I was watching Deep Space Nine.
Oh yeah,
you've got to, haven't you?
But really, one of the tools that a lot of astronomers uses to actually see and analyze the fits of telescope images, like any photometry images or even spectra, is called SAO DS9. And a lot of people think that DS9 instead, because there was a DS8 version before. No, the version before was TNS. So they actually named all the version of this tool after the Star Trek TV series.
Yeah. Well, I actually, yeah, I've got DS9 on the computer in front of me for taking the FZ files into FITS for the Forks images.
Yeah.
So there we go. So yeah, so anyway, I'm going to hand you over to our panel, our illustrious panel, who are going to ask you a few questions, if you don't mind at all.
Yep.
Okay. I'll open it up and try and think of a rapid question. So when a star explodes, what is the difference between a standard star, let's say, going supernova, we get our supernova type 1A, compared to the supergiant supernova? What is the difference between the after effects? Because a supernova obliterates itself. You may end up with a neutron star at the center, I think. You'll have gravitational waves moving out, and all the debris and gas and everything that was there is spreading out like the Crab Nebula. So what about these supermassive supernova? What do we see that's different?
Okay, so the stars which I usually specialize on and focus on my entire career, everything that is uncommon. So everything defies the standard scenario, the standard mechanism which everybody thought they would actually understood is my forte. So these 10 years ago, now 11 years ago, we discovered these kind of very new stars, which we call new supernovae. We called super luminous supernovae because they were, as you might guess, they were more luminous than normal supernovae. And they were 10 to 100 times brighter than any other kind of supernova, including the thermonuclear supernova that you mentioned. So there are basically two main channels to form a supernova. The first one is the thermonuclear one, where you actually have a white dwarf, which is a paradigm of stability. You can, if you leave a white dwarf, which is a degenerate star at the end of its life alone, and it doesn't have a companion, there is no way it's going to change its status. It will stay a white dwarf forever and ever. There's no way that changes. However, if there's a companion, if it's a little body that actually is poking the white dwarf saying, oh, why don't we do something different? The white dwarf is actually going to get material from the companion, and it will eventually arrive to a limit where it cannot get enough material and will trigger nuclear reaction exploding. So there's one way to form thermonuclear supernova, or you can also have with two white dwarfs colliding into each other. There is the other mechanism that we knew is the one of core collapse supernovae, which is the one that producing gravitational waves, although that's very feeble, they're very little and not so much intense as the one that usually got by LIGO. You have a gigantic star, which usually is at least 10 times more massive than our sun during its main life, which we call zero-age main sequence, and they will eventually run out of fuel. Running out of fuel means it doesn't have the pressure to keep on all the material, which is trying for the entire life of the star to actually to go to the center due to gravity. There's been all this fuel that was actually pushing out, and it was basically balancing the force of gravity. And then the fuel runs out, and just in less than a snap of a finger, everything will collide and then will bounce back, creating a supernova explosion and leaving a remnant after it, which is the neutron stars. So only the core collapse supernova can leave the neutron stars behind. Thermonuclear supernova, they will destroy everything. So if you will get supernova remnants, nebulae, with nothing in the center, that were coming from the thermonuclear. While if there is something in the center, that was a core collapse. Then there are these superluminous supernova, which they're far brighter. You cannot create them with these simple mechanisms. You need something else. You need an additional source of energy. You need something which will boost the luminosity we see. So the main idea behind these objects, it was published in a paper of mine back in 2013. And it was basically the possibility of that the remnants, they were normal core collapses of very massive stars like we've seen before. But the difference was that the remnant produced, it was not a simple neutron star, but it was something we call a magnetar. A magnetar is basically a neutron star with just one important difference. It has a magnetic field which is 10 to the 14 times stronger than the one we have in our planet. So it's called 10 to the 14 Gauss. The one on our planet is just 1 Gauss. And that's the magnetic field that we use with the compasses or the birds use to actually travel from the north to south. That is the difference. So that incredible magnetic rotational energy of this magnetar is ingested into the supernova explosion, giving an extra kick of luminosity. So it basically has two power sources, the explosion and the magnetic energy, which basically boost it to super luminous luminosities. So that's the main difference.
Yeah. So how many would we see or detect in 12 months over a period of a year, maybe?
So that's
common?
That's the trick. No, they're absolutely not common. Yeah. They are fantastically rare. And by now we roughly see, looking at the whole sky, between 10 and 20 objects per year. Sometimes we go to the 10 sides, sometimes we go to the 20 sides, if we are lucky. So far, you have to think that since we discovered them, we got 180 superluminous supernovae as of today, give it or take. And they are a factor of 10 to the minus 5 rarer than any other core collapse supernova. Right. When you say just 10 to the minus 5, even if you are not that experienced in maths, you say, oh, 5. It's going to be really, really low. It's really low.
Yeah. So obviously, fast detection, if these are so rare, hopefully the telescopes are there, detect them, and wherever in the world, you want those telescopes to quickly point to that portion of the sky and get detecting.
Is there light curves like other supernovae, but just longer, or does it have any particular characteristics?
It is also longer. So that's good because it actually gives us much more time to detect them. And we also have another important advantage. So it looks like the majority of these superluminous supernovae appears in very metal-poor environments.
Right.
Which is basically everything was back at the beginning of the cosmos before all the cycle of death and rebirth of stars, from population tree stars up to our sun, created more and more metal in the universe. Right. That means we can observe them. They're already very extremely luminous, so we can observe them even further than even type 1a supernovae. And they're actually, they favor that kind of environment we see back in time or far in distance. So and because of special relativity, basically the light gets elongated and bended. So the further we observe, the slower these objects will appear to us, even though they are not slower if you are just in front of the supernova, but they will appear slower because of special relativistics effect.
Right.
So it takes roughly an average of 30 days for a superluminous supernova to reach the maximum luminosity. But if you put that already at a redshift of 2, which basically means roughly 5 to 6,000 megaparsecs far away from our planet, instead of 30 days of rise from the first light to the peak of luminosity, we will observe a rise of 90 days. It's a factor of 3, just a factor of 2.
Wow. And how long is that visible for? How long does it take before it fades away altogether?
So of course, it depends on the distance and as a consequence of our capability of getting. So
compared to the climb towards the peak, how long is the tail off, if you like?
Is usually a factor of 3 to 5 longer.
Right.
So
that's really long.
We observed superluminous supernova. One of the closest, it was at the same distance of other supernovae. We ended up observing that up to 3.5 years after, thanks to the Hubble telescope.
Okay. Excellent. I'm supposing...
Statistical...
Sorry, carry on, Rob.
So I was going to say, was it the statistical analysis of the light curves that made you realise there was this different category of objects?
We saw these, yes, we basically saw that not only the luminosity evolution, so the light that comes to us, but also the spectroscopic signatures were different from anything we have seen before. It was something like seeing the electromagnetic spectrum of a normal supernova frozen in time. So at a certain point we saw, it doesn't change. The temperature changes. The temperature doesn't change. Nothing changes, but the luminosity changes. That's not physically possible. And then it just because possible, this is one of the consequences of the ingestion of the magnetic field.
Wow. Can I ask? Sorry,
Andy, can we just bring Daz in quick?
Yeah, come on.
I was just thinking, you were saying that these supermassive stars are back in time. Will you be using, well, fingers crossed, will you be using the James Webb telescope? Because that's going to give you a better...
So there are projects to use the James Webb telescope. However, the main difficulty at the moment is that because they're rare, you need some other telescope that say, oh, look, there is a superluminous supernova at that distance. And then you go with the James Webb telescope, something like, ooh, I have the coolest telescope with the best resolution and the best depth in the world and atmosphere. And I can get far more information for a longer time, but you still need a feeder. You need what we call a feeder survey. And in that case, we do have two potential feeder surveys, which will come online in 2023, which are the Vera Rubin Observatory, which will observe, we predicted with a lot of other UK astronomers and the European astronomers that we are going to end up having roughly 500 to 900 superluminous supernovae in 10 years from this Vera Rubin Observatory from 2023 to 2033, up to distances higher than anything else observed so far. And then there is going to be another European project, which is called the Euclid Satellite, which I'm also a member of, which will be launched in 2023. And that is a near-infrared satellite. And that will actually, we can get superluminous supernova up to redshift 4, which is a factor of 2 further than any current observation of superluminous supernova, and a factor of 5 further than any other supernova ever observed.
Oh, excellent.
Wow.
That's brilliant. Yeah, because I also know that your investigations also involve AI, artificial intelligence, and you're looking into implementation to use it basically to implement use classifying and categorizing supernovae. So is there something you can tell us about that?
Yeah, so there are a lot of endeavors around the globe trying to actually getting to understand what kind of supernova are we seeing just looking at the luminosity evolution. So far, the main approach has been, oh, we have the luminosity evolution, so we have these light curves, which is changing. And then we say, okay, there might be these objects, there might be these other objects. And what we get is we get an electromagnetic spectrum out of it. So basically we get, when I say electromagnetic spectrum, it means there is going to be, we have the information photons per wavelength. So we basically see all the chemical elements, and then we say, okay, that's this kind of explosion, or is that kind of explosion, and we pair the two information all together. However, because of this new observatory, like the Vera Rubin, we are going basically submerged by supernova discoveries. The Vera Rubin Observatory is going to provide 23 terabytes of data per day, per night, per 365 days per year, per 10 years, no stop. So that's nothing. It's impossible for human beings to cover all this. So even if you take all the telescope in the world that have spectroscopic capabilities, and you say, I'm going to do all the supernova, you get 20, possibly 30% out of them. Still is not enough. So the idea is, let's use AI to tell us what kind of supernova we're looking at just from the luminosity evolution, but not after 20 or 30 or 50 days, we have seen the entire luminosity evolution. And then anybody which is a little bit experienced in the field would tell, oh, this is good chances is 1A or good chances is a core collapse. No, well, the interesting and challenging bit is do that in the first couple of days. So if we ended up having something which is extremely exciting or is important, like superluminous supernova rare, we can actually start to get information soon enough. And then the earlier you get information, the more physics you probe, and the better the explanation, better information you will have to really understand the physics behind it. So that's the main idea.
Yeah, it's fantastic.
Can I ask you about the the gravitational wave aspect of these super luminous supernovae. Before that, well, not really interesting, but when I was a young man, and contrary to popular opinion, I was once. I spent 25 years living in a village called Llantwick Major, about 18 miles west of Cardiff. I don't know whether you know it, but anyway. And I worked in Cardiff for the electrical store Dixon's. And one day, a gentleman came into the shop by the name of Bernard Schutz.
Oh, Bernard.
Yeah, you know Bernard.
Yeah, I know Bernard.
Yeah, this was 1987. Okay. And we just got chatting, and I said, asked him about his work, and he said, well, I'm doing some of the maths behind what would become LIGO. We're just doing the initial sort of maths research and whatever. And I started following LIGO from that moment on. I was so fascinated. And I got in touch with him recently because as you probably know, he's got a wonderful blog. And I said, you probably don't remember me, but in 1987, you really inspired me to follow the whole LIGO story in gravitational waves. And he said, no, you're quite right. I don't remember you. But he said, I'm glad that you've carried on following it. And the year before last, I went to give a lecture to at Trinity College Dublin for Astronomy Ireland on the subject of gravitational waves. And I thought, I never dreamt in 1987 I'd be standing up here talking about this stuff to an audience. And it was quite wonderful. Anyway, put that story aside. What I wanted to ask you was, we've got sort of stellar mass black holes radiating gravitational waves that are measured in a few hertz. Then at the other end of the scale, we've got supermassive black holes that might generate gravitational waves in the nanohertz range. Where do your supernovae come in terms of that?
So unfortunately, these supernovae, I think they will never produce a strong gravitational wave signal enough to be detected by LIGO. Even with the new upgrades that are going to be online.
But in the future, theoretically, the technology is possible.
You will still need something which is in our galaxy.
Right.
Or with really future and something which at the moment is unthinkable, you might end up with something in our satellite galaxy, like the Large Magellanic Cloud or the Small Magellanic Cloud, because at the end of the day, luminous supernovae, they are not that different from normal collapsing stars. They are the same. It's just the remnant products that they changes, but the gravitational waves are actually created during the collapse.
Yeah.
Because of that. So that will not be any different.
So we're talking low frequency waves then.
Yeah.
Yeah. Yeah. Because and even Lisa won't have the capability of. No, I didn't think so.
No.
I'm sure Lisa will discover many amazing things, but I think that's.
Oh, it might be. I mean, if we get something in our neighbors, it still might be possible.
Yeah.
I mean,
but that's a bit unlikely, I presume.
Yes, I don't know about all the details about the capability of Lisa, but the closest we had so far, it was now 24 years ago. It was 1987A in the Large Magellanic Cloud.
Yeah, I remember it well.
And
Juliac.
Yes, still visible. It's still there.
Yeah.
The only reason I remember that, and I've mentioned this before on the show, my friend Rob Johnson, he got married, went on his honeymoon, and he went to the southern hemispheres, and he insisted on taking a photograph on the evening of his honeymoon. His wife was impressed.
Oh, fantastic.
So San Juliac, 1987, I remember it well. And the two of us have followed it ever since, and we've watched it expand over the decades now, isn't it?
I got interested because BBC Horizon did a special on it. BBC Horizon did an excellent episode on 1987A, and like you, I've followed it ever since. Mm-hmm. And they think now that they may well have detected the neutron star at the center of it.
Yes, so I've seen there was some claims from, I think it was a group of Italian astrophysicists.
Yeah.
It's actually, they come from my same island, but on the other side. Yeah, I think I came across this news, and I'm quite sure they were coming from a city called Palermo, which is on the same island where I grew up.
Ah, right.
But in truth, even Cardiff, there was a paper about last year, I think it was, or 2 years ago top. It was led by one of our research associates in Cardiff University, was Phil Sigan, and there were other two academics that assigned the paper was Dr. Mikako Matsura and Professor Eili Gomez, that actually there were a claim about an indirect signatures of the neutron stars in the middle of 1987A, and it was due to the dust destruction and
that's right
in the color.
They found a blob, didn't they, that had an infrared excess.
Yes.
That they couldn't explain any other way than, there's a neutron star behind it.
So the thing is, basically, we know that there is a neutron star.
Of course, there has to be.
It is just we have to wait to find the right information to actually say that's true. There is a neutron star behind it.
Yeah, absolutely. Yeah, it has to be there. It has to be there.
Yeah,
it definitely has to be there.
Or we have to revise our knowledge of physics, and that would not actually be the first time.
No, and that might be a good thing. I mean, that's never a bad thing.
No, absolutely not.
So
I agree.
But I think in this case, I'm prepared to put money on there being a neutron star there.
Yeah, me too.
Yeah. Oh, it's great. Thank you.
Yeah.
You're welcome.
Well, I've had a question come in, and basically the question is, how common is it, and how do you get two neutron stars just happen to be so close together? Does one larger mass attract the other? Because basically you got two stars that have gone supernova, maybe. Neutron stars remains, and then you get two neutron stars that will basically collide into each other. So how does that happen? Stars are far apart, basically.
So stars are far apart.
Yeah.
And then basically one of the two of them, they might evolve in different time scale as a supernova. And basically the evolution of one of the two as a supernova will basically change the evolution of the other star, which will ended up possibly not being a supernova, or just being a different kind of supernova. And as a consequence, their combination of gravitational potential of the two stars start to change and becomes stronger. And then basically they decide to do some kind of, I'll pull you, no, I'll pull you, no, I'll pull you. And at a certain point, the two neutron stars, they will something like, wait, we're both there. So we will end up pulling each other because they're already inside this gravitational spin of the two of them, and they will eventually spiraling into each other. So how common it is? Not that common, but still more common than superluminous supernova.
Yeah.
We're there.
It's an amazing universe.
It is. I just think myself, it's a fascinating universe. It's we say it's endless, basically, isn't it? It's just every time we think we've got the answer, something else comes up, and there's another question which opens up the door again. And you go further on, you find these infrared blobs somewhere, and you got to find out what's caused that. Where's that happening? And it is.
Yeah, we should.
Amazing, isn't it? But yeah, it's amazing.
Yeah, we should not forget 50% of all stars lives in binary system. Statistically, so not just because we see our sun, which is a single star, we have to assume that everything goes in that way. Actually, not. One out of two is in a binary system.
Cool.
Can I just ask? Are there any competing theories to your magnetar theory for the source
yes,
of the superluminous?
There are. So there are actually three theories. There was the magnetar, and then there was the idea of that. There was the standard idea when we see something which is more luminous is basically the stars which explode as a supernova gets to interact with the previous material expelled by the stars during its normal life in terms of winds or single outbursts of explosion due to some kind of instabilities in the external layer. So what's happened is the material expelled by the supernova, it founds this other material expelled between thousands and billions of years before. It gets slammed on it, and then basically this slamming of two material creates shock waves, and that shock waves will create additional photons. However, the main counter argument for this theory is that if you do that, you see some specific signature in the electromagnetic spectrum in terms of the profile of the elements and the composition of the element, or the yields of the elements. So how much of each element we see and what kind of form and velocities. And we have never seen that, never. Even at earlier phases, at later phases. So we still are missing the first week or 10 days soon after the explosion of a superluminous supernova. We have never been able to actually take a spectrum. That epoch, which is one of my many projects, is actually to find a way with machine learning to actually get that epoch with artificial intelligence to get that epoch, and then we say, oh, that's a superluminous supernova. The AI tool is telling us, so let's get a spectrum and see if actually we can rule out this theory or not. Another possibility that has been suggested for a long time, it was a completely different kind of mechanism, which is called pair instability supernova. A pair instability supernova is almost the same identical concept of a thermonuclear supernova, but the triggering is actually the stability between pair couple of proton and antiproton and different kind of elements. And what's happening is that there are these instabilities and the star explodes. However, there are some caveats. So pair instability supernovae, to explode, they need to be almost metal poor star. So we have seen these in low metallicity galaxy, but they're still metals. The pair instability supernovae, they need to be at zero metallicity. So in fact, that is the best candidate to explain the first supernovae back at the beginning of the universe. But the other things that because of these pair instability supernovae, they're very massive stars. We're talking about 500 to 600 times the mass of our sun. So this is a really, really gigantic stars which will explode. But because they are so much more massive than any normal stars, they will produce more isotopes, which will decay and create photons. As a consequence, the luminosity evolution would be even at times 2 to 5 even slower than what we observed in superluminous supernovae. So superluminous supernovae are basically the slowest of all supernovae and also the brightest, but these pair instability are even slower. And how the luminosity evolution behave, it is not as we would expect it from a pair instability supernova.
Okay. So you've got the best theory out there at the moment. Is there something in the future?
Unfortunately, so it looks so.
So is there something in the future, other than, say, getting that first epoch, that's really going to nail it down to actually that is going to be magnetar-based?
Yes. So the other theories, so we had another theory was looking actually the geometry of the stars, which we did. And we actually saw that these stars, looking at what is called polarization, which is how the light is bended because of electric field or magnetic field, it actually shows that the geometry of these supernovae are like a rugby ball. So it would be perfect for whales in this kind of sense. So it's not absolutely spherical, it's really a rugby ball. And we see that the further we look inside the supernova material, the more rugby shape, so the more an oval the geometry it is. And that is actually only possible if you have something with two jets or a preferential axis, like a very fast spinning neutron stars. So that's the only way to get it, because with interaction, there is almost no shape. You should see roughly something which is spherical, because you do not really see one single element, you see two materials. And so all the composition is going to be really difficult to have both of them elongated in the same way. And especially because if you do already lose material in that way, you will lose angular momentum. So you will rotate not that fast. And then the second material is not going to be that shape. And for the pair stabilities, they're gigantic balls. They really are balls of materials. So there is no way you get that degree of asphericity. So there was a strong suggestion with something it was bipolar, but it doesn't say it has to be a magnetar. It can be a pulsar, it can be a neutron stars. So from my point of view, the real nail in the coffin for the magnetar scenario is X-ray. So if you get an X-ray emission soon after the birth of the superluminous supernova, that's the magnet. That's synchrotron. It's the only physical mechanism that can create such a gigantic X-ray at that moment into the stars. And from synchrotron, you can actually get the source of the synchrotron and then get information about the magnetar itself. So that would actually be
amazing stuff. It's really amazing stuff.
Yeah. I was going to
Andy, could we just let Paul in? Paul's had his question ready for a while there. Paul, over to you.
So, thank you, Dr. Inserra, for talking about your fascinating day-to-day job of preserving the universe. My question comes as from the standpoint as an educator. I'm keenly aware that there's saying that you can't be what you can't see, and yet sat in front of me in my classroom on a daily basis could be the first person to set foot on Mars. Can you describe a little bit about your journey into your scientific research career, and what skills, qualifications, and experience you'd recommend to the next generation?
Sure, absolutely. Okay. First of all, I have no idea who Dr. Inserra is. I'm Cosimo. Nobody calls me Dr. Inserra, neither my students. I always encourage that. We are all people. We have first names. We have no titles. What I care. So second of all, so first of all, I would suggest passion. I think that for me has always been the main reason. If you're passionate about something, you will always give 200%, and you will get even 200% in terms of satisfaction in what you get after it. I think that is the best balance in terms of even a healthy mind and a healthy attitude. Second of all, I think by any means you need to have a certain good skills of science, but it could be maths, it could be physics. But I think there are two important things for me are even more important than physics and maths, because at the end of the day, I'm quite sure that 90% of astrophysicists will have to go and look up all the questions in the books. Nobody remembers all the questions. What we remember are the basics, are just the logic behind it, the cause and effect of everything in nature. That is understanding that, having a solid logic, and sometimes a lot of thinking outside the box. So I think the best quality, the best trait, the best skills in a scientist is always question themselves and always question the basics. So that's the most difficult part for a lot of people. If you think you have the basic to understand something, and as soon as you have understood it, you have to say, okay, let's assume now that the basics are wrong. How do I do that? How can we interpret everything without knowing what I know? So always challenge themselves and have fun. That's if you think it is fun, then I think you're suited to do that. And I would wholeheartedly recommend it a lot of people to try, because now it sounds strange to say, but I think it's not that complicated. Lots of people, when I said, what do you do for a living? I'm an astrophysicist. They say, ooh, this is weird, complicated stuff. It is not. Nature is absolutely amazing in the way it defies what we know. And at the end of the day, all the basic physics principles are basic. You just need to do like Legos. You just to build brick after brick your understanding, and then dismantle, don't follow the instruction, and do something by your own.
A very positive
good answer.
Yeah, very positive message out there, I think. Yeah,
absolutely.
Just as another sort of like going off at a tangent, I noticed another one of your pies that you've got a finger in is dark energy. What's the state of dark energy research at the moment?
Does dark energy matter?
Yes. Yeah.
Darkly.
It seems it matters. So, yes. So one of the unfortunate routes that I decided to take in my science, it was try to see if these luminous supernovae could be used in principle as standardizable handles in the same way it has been used for thermonuclear supernovae. To just say that in lay terms, a standardizable handle is an astrophysical object for which you know how to make an average, how to make, let's say, a paradigm of your entire species with some observable knowledge, something like, and you use that observable knowledge to make all the objects that you know of it identical to your prototypical one. That is basically the entire ethos behind being a standardizable handle. And if you can do that, you know, okay, if I know what is the prototypical, and I can link anything I see to that one, as a consequence, I know the luminosity that this guy is emitting, and I can retrieve the distance. So that's how we use supernova in cosmology. And to do that, you can actually check how these distance evolve based on these luminosity distribution of these supernovae. And then you can see if the data lies with one theory of evolution with respect to another theory of evolution. So what we've done so far is it's very timely. I'm actually resubmitting my papers on these matter to the monthly notice of Royal Astronomical Society, actually next Monday, with the Dark Energy Survey collaboration, which we actually seen that we can use these or at least we think it's possible to use one subclass of these superluminous supernovae to explore the evolution of dark energy and dark matter. And we found the same identical things we have been seeing with type 1a supernova, but we just confirmed that that is true even at further distances. So wow. the physics still holds, but take that with a glimpse of salt, because of course we have far less objects than thermonuclear supernovae. Thermonuclear supernova science has been, and cosmology has been done and corroborated with 1,000 of supernovae. We have 20, which we can use. Good. So one thing's in the future with all these new observatory like the Barrow Rubin or Euclid, if we can get all of the superluminous supernovae, we will have the same precision we have right now with type 1a supernovae, with thermonuclear supernovae. With the good things is that we have the main problem of thermonuclear supernovae to get even more precise measurements is not statistics anymore. They have enough of them, but they are what we call systematics, are uncertainties, are errors in things we do not understand how to evolve. And one of the main uncertainties is the production of molecules of dust into the interstellar matter and in the galaxies hosting these thermonuclear supernovae, because in my work, completely different than our galaxy. Mm-hmm. But that is fantastic because superluminous supernovae, they appear in low metallicity galaxies where there is almost zero dust production. So we don't have that problem. So what we need is two main things: more superluminous supernovae and someone smarter than me to really understand what they are, so we actually know that we can use a standardized Blob candle or not.
That's amazing.
Yeah, fantastic.
Yeah,
that's fantastic.
Okay, we're getting quite a few questions coming in from our listeners. We've covered a lot of the subjects. So a lot of the questions that are coming, we've actually covered them. But we wanted to, Robin in California is asking if you have a telescope at home, or do you have access to a telescope where you can observe with? I think this is actually visually looking through telescopes, like what us amateurs do.
No, because I gave up about him since I came to the UK. I thought, okay, it's never going to happen. So it's something like, I know. And to be honest, I met even a lot of amateur astronomers in the UK, which have done a fantastic job. And I absolutely have the outstanding admiration for all of you, because I would have given up ages ago. I'm not that passionate. I'm something like, okay, I'm not going to do that. I'm going to the bed. It's too cold. No, it's too cold. No, it's too cloudy. No, it's too cold. No, it's too cloudy. But it's too nice. I'll just have a beer outside.
Yeah. Well, this is what makes us good observers, because when we get those clear nights, we make the most of it. Usually we're fast asleep, unfortunately. But okay, we get a lot of percentage of cloud, and we do have rain. But then, UK is beautifully lush green, isn't it?
Yes.
I love Spain. I love Europe, but most of it can be very brown at times.
Excuse me. I live in Catalonia, and it's very, very lush and verdant here.
Okay, well, when we come over for that barbecue, you can take us on a tour.
All right.
Okay. Tian in Japan, one of our regular listeners, he says he's inspired by just listening to what you have to say. You're an inspiration, which is beautiful, isn't it? Again, Jill in Dublin, she asks, do you do outreach lectures? Obviously, I guess via Zoom these days. I
used to do them a lot. I've been at the Trinity College Dublin for Ireland, Astronomy Ireland. I've been in Belfast for the amateur astronomer. I've been at the Open University for the British astronomers. I've done an outreach event in, it was in It's close to Southampton. They have a fantastic planetarium over there.
Not Bath Astronomy, is it, by any chance? Because they're fantastic as well.
It's not Bath Astronomy. It's
Simon. Not sorry. It'll come back, I'm sure.
So, but since I became a lecturer, apparently I was selected by lots of people to do a lot of admin duties, which were not outreach. So I ended up doing a lot of admin duties, which, to be honest, I also like, and lots of things I'm passionate about. So I ended up not having a lot of time to outreach. But I was absolutely okay with it because there are fantastic people in Cardiff for outreach.
Yeah.
Yeah.
So is the answer no then in that case? You do not do any outreach lectures at this moment in time?
I was trying to not go for a no, but at the end of the day, yes is a no.
Cosimo, can I just ask you, when you were at Trinity College Dublin, did you get the same immense thrill that I got lecturing in the Schrödinger lecture theatre and standing where Schrödinger stood in exactly the same place looking out over the audience?
But Andy, was the audience awake or asleep?
The lights are out. I couldn't really see.
Exactly.
Yeah. There was the sound of snoring at one point, but anyway. But apparently they've still got Schrödinger's gown that he wore for lectures.
Oh, really? Wow.
Yeah, and they don't let many people touch it. But I'm trying to wangle it the next time I go over. I might get to touch Schrödinger's gown, which will be.
You'll have either touched it or you won't.
Exactly.
Well, yeah.
where it's all
very
not.
droll, Pete. Very droll. Yeah.
No, well, I did a lecture in there on the Sun as well. So there's 3 of us being in that theatre.
Isn't it an incredible place?
Absolutely fantastic.
And it's got the original benches at the front. That they hadn't touched since Schrödinger's day. It was such an honour to be there. It really was. It was just a big high for me. I didn't come down for months after that. Nothing else matched that. Even my wife. And it was,
I hope you're not telling her that part.
It's just he's only
she doesn't listen to this.
He's broadcasting it.
So she left me last year, so I can say these things now.
That was probably because you kept saying things like that.
Yeah, probably. Yeah.
So back on the astronomy subjects. Any further questions from our panel regarding astronomy?
No.
So should we lighten it up a little bit?
Yeah.
Can I just ask Cosimo? Was it your walk? Was it your work that brought you to the UK?
Yes.
Right.
Yeah,
and it must have been a bit of a shock of changing climate for you.
Truth, I really love the UK. I have double citizenship now. We moved to Belfast soon after I got my PhD. And then with my wife, they said we love the UK, and then we said we're going to stay here. So I got other awards during my career, which I declined to not move from the UK, even if there was not possibly the smartest career idea, because I actually basically turned down promotions when I was a postdoc. So I got 4 more prestigious postdocs and awards, and they say, okay, it's fantastic. Can I work with you but stay in the UK? No. Okay. So family comes first. I will stay here. I'll try somehow.
Where were you in Belfast? Were you at Queen's?
Yes, of course. Everybody does astronomy is in Queen's.
The Queen's.
Absolutely. Yeah.
It's brilliant. I love Northern Ireland. My wife's family are all Northern Irish, and we used to go over an awful lot, but their dad then moved to the Isle of Man. So now that's the location. But I do like Northern Ireland.
Yeah, I would prefer Northern Ireland than Isle of Man. No offense.
No, I'm with you on that
one. Ireland is a beautiful country, totally, isn't it? Really.
Yeah,
lovely people, lovely country. Yeah,
the people are just absolutely unbelievable.
And of course, we got St. Patrick's Day coming up very shortly as well.
Oh, we'll have to do a St. Patrick's. We'll have to do a St. Patrick's Day show.
What day of the week is it on? That's the question.
Well, we can always fit one in.
Yes.
I had a funny moment when I was in Belfast because my wife was originally from there, and I was on a roundabout at traffic lights, and the chap next to me wound his window down. He says, "Hello there. Can you tell me where the Falls Road is?" And I gave him directions, so I knew exactly where it was. Not that And I accidentally went up there the following day by mistake by going off the roundabout too early. My wife says, "Shut up. Just come to the end of the road.
Do not say anything. Keep that.
Don't say anything."
I mean, to be honest, I've been in false world a lot of times.
Past the era.
And we've been past the university, yes.
Yeah.
Okay, let's bring it to a slightly different subjects then. You mentioned sci-fi, Cosimo, and that you, in particular, like Star Wars.
Mm-hmm.
So, would you class yourself as an expert in Star Wars trivia?
Or even an expert?
Ooh. I mean, my ego would say so, but I'm not.
Right. I'm going to put this one to you now. We do lots of outreach there. Liverpool Astronomical Society and other societies, of course, do lots of outreach with schools of different age groups, scouts and guides, and imagine all the outreach events that you can do. So we have quite a large audience out there. But one of the things I love is engaging with the kids. And certainly when the Star Wars films were at the peak of the seasons of the time, we used to ask them about meteors and meteorites. A lot of them had seen shooting stars, so they knew a shooting star was the streak of light across the sky. Some of them realized that a meteorite is what actually lands on the ground, the result from a meteor or shooting star. So we'd chat about that. And then I'd pass samples of meteorite around the table. So we have an audience of maybe 15 or 20 young uns there. And one of the meteorites in particular always raised their eyebrows. And you can see the question marks, and occasionally there'll be a light bulb that would come on. And basically, we talk about the different types of meteor or meteorites, the stony meteorites, the iron meteorites, and the stony iron meteorites, and so on. We actually purchased a friend of the radio show, Martin Goff, runs MSG Meteorites. Bit of an advert and a plug there. MSG Meteorites, www. Everyone go and have a look at that. Some amazing samples of meteorite that you can purchase. And one in particular was a meteorite that I'd pass around to the audience, the young ones, and I'd ask them, this one was from South Africa, this one is from Africa, SA, whichever. There are all these reference numbers, and we'd chat about that. And then this one in particular, I'd let them read the box, and I'd say, okay, where's that one from? And they'd say, Tatooine. I hope I pronounced that correctly. Does that mean anything at all? Tatooine or Tatooine?
Tatooine, I think it is.
Tatooine. I think there you go. It's just the way I pronounce it in Scouse, in my Liverpool accent. And the young ones would look at me because I'd ask them, any Star Wars fans, that the hands would go up, and I'd say, how much of a fan are you? Oh, I'm a big fan. You see the excitement in the kids. Are you a bigger fan than him? Oh, yeah. Who knows the most about Star Wars? I do. So I'd pass them this meteorite, and in the little box it'd have the label, and it would say Tatooine, whatever it is, and they'd look at me and go, and there'd be this quizzical look on the face. Well, hang on. And I'd say, what's the problem? And they say, well, it's from Star Wars, but it's just a film. But I say, no, that really is from Tatooine. And they would question it, just basically, what is he on about? It's just a film. It's just a book. But they know Tatooine is where. I'm going to ask you who was born on Tatooine. That'd be the question.
I mean,
I'm putting you on the spot here with a 250,000 people listening.
All the Anakin Skywalker.
There you go. That's the answer. Luke Skywalker. That's where he was born. He's a little lad. That's where he is. So.
And Anakin.
No, actually,
I'm not into Star Wars. I'm a Star Trek fan.
Luke Skywalker was not delivered on Tatooine. Luke Skywalker was delivered on a spaceship.
Yeah.
It was then brought to Tatooine. All the Anakin Skywalker.
See, this is what you learn on this program.
He was born on a spaceship, and as they looked out the window, there was a galaxy sitting there, if I remember rightly.
Yeah, it's always the ending of any Star Wars. So you see that this
galaxy,
like at the beginning, you always have kind of
that moment. Well, so this meteorite is from Tatooine, and they look at me quizzical, as I say, and I say, it genuinely is from them. They will, how can it be from there? It's just a film. I say, because that's where it was found. Meteorites are all known by where they're found. The Barringer craters, the Arizona crater, the Chelyabinsk, and so on. They're all named after where they were found. So I said, well, that's where it's found. And it was basically that is a place, a little village in Tunisia.
And that's really?
And that's where they filmed Star Wars. So you remember that scene where it's the hemisphere houses, that's our best way to describe the little village where he is when he's a lad. That's where they filmed that in the village or the town of Tatooine. So that's where it was filmed. That's where the meteorites had landed many hundreds of years before. And that's why it's got that name. So there was a link with the meteorites and the Star Wars. And basically, it just got the kids engaged at that moment and the smile on the face. And then I told them it's actually a piece of Vesta. It's the asteroid.
Oh, really?
It's
wow.
come from the asteroid Vesta. So what we do with our outreach when we get those very rare clear skies in the UK, we stand out there. And I think Vesta is visible at the moment. So if anyone gets out there.
I thought that was a curry.
Yeah, it's a pan of curry, isn't it, Vesta?
It is a pan of curry, a type of recipe back in the 70s.
And a powdered paella, if you remember those. When British people thought they were really sophisticated going on holiday.
See how we go off topic and come back again.
They wanted to come back and eat Spanish food.
But Andy, you used to get your little packet of soy sauce with it.
That's right. And Vesta rather cunningly thought, we're going to capitalise on the Brits going to Spain for the first time, and we're going to give them paella, but it'll have to be in powdered form. It was disgusting.
I've lost my track now. Where was I? So it's actually a piece of the asteroid Vesta. So MSG Meteorites, get in touch with Martin, and you can actually own a piece of Vesta. Stand outside and look in this region of sky. And if you can get your binoculars or a telescope and find Vesta, it's reasonably brightish as far as binoculars go. And you can actually hold a piece of Vesta whilst looking through the telescope or the binoculars at Vesta. And that's what we do at the observatory when we get those rare clear nights. We actually stand there with a piece of Vesta in our hands, looking at the asteroid through the telescope.
Amazing. What experience.
It's a buzz. It's just...
Yeah.
It's sort of going boom, 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 boom. Yeah.
Yeah.
So there you go.
It's like holding a piece of cheese while looking at the moon, isn't it?
Well, as long as it's Wensleydale. Yes.
Yeah, of course.
Well, the cheeses are available.
I was just looking because I've got a piece of that Tatooine meteorite.
That one, yeah.
Because when I did a talk at the Skellig Star Party down in the south of Ireland, they gave us all a piece as a little gift, a piece of the Tatooine meteorite. So
yeah,
I was just looking for it. I can't find it. I found I can't even pronounce it.
That one, yeah,
the Russian one. Yeah. That was
it's great to pass these bits of meteorites around, and then you get the Libyan sand or the Libyan glass, which is basically impact where the meteors impacted with the sand and melted the sands and obviously the silicon, whatever. And I always say to the kids, what's glass made of? Main thing is silicon. Basically, when that melts, you get glass. So you get this, and then you polish it up. You can make jewelry out of it. So it just puts them into hands-on, and you go out there and look in the sky, and they see a meteor go past. And next time they see the shooting star or meteor, they go, right, we've actually held a piece in our hands. And depending on the age group, I always say, well, you can wish on a shooting star. So you can wish on these stars as well. So it's just a nice little
fantastic. That's
little
quite
contact.
Nice.
I love doing that.
Yeah.
So there's a little bit of Star Wars trivia that you can use freely, and I believe it is accurate as well.
Now that we've corrected you, yeah.
What did you correct me on? The pronunciation.
Yeah, definitely.
Well, the pronunciation, the actual child that was born there.
Yeah.
The story was great.
I'm not a Star Wars fan.
The film.
If somebody said to me, "Where's this from?" Even reading the box, it wouldn't mean anything to me. I just go Tatooine.
The word Tatooine, Dave. Tatooine.
It's written in Scouse.
Oh right, of course. Yeah.
Cosimo, Scouse is the accent of Liverpool. The dialect of Liverpool is Scouse.
Tatooine sounds like a Scouse escapologist.
Escaping from the Death Star. Tatooine, starring Tatooine handcuffed. He's wearing a straitjacket as he escapes out the escape hatch. Getting silly now, Andy.
Yeah.
Oh, I'm always
but always funny though. I like it.
Okay. Well, we want to thank you for coming in tonight, Cosimo. That's really appreciated you coming on to Astro Radio.
Round of applause for Cosimo.
Yeah.
Thank you very much. It was a pleasure. Thank you very much.
We're going to go to another track now, but you're welcome to sit in and listen to the waffle that carries on afterwards.
Join in with the waffle.
You're quite welcome, but I'm going to go over to a pre-med track, and this is Up All Night.
And Cosimo, do come back and tell us about your work. You're welcome back anytime.
So, hi, Paul, again. So you enjoying your first night here in Astro Radio's chat?
Very much indeed. Thank you for having me.
Well, you're welcome anytime. So you say you're an educator. You teach in schools.
That's right. Yeah, I'm secondary school physics teacher.
So which secondary school are you at?
I'm at Bromsgrove School currently.
Yeah, I know it. One of the things we do, and we probably might start doing this online. We used to do this live when we were allowed to go into the schools and what have you. We take an outside broadcast unit into schools and allow the kids to broadcast their science projects on air. So I mean, if you want to do that one day, we can always set it up via Zoom, and they can come in and have a chat about what they do, their science projects or whatever, and go out on air and have their own little radio show.
That sounds absolutely fantastic. Thank you, indeed. That's a great opportunity.
We did a lot of this. I remember doing one at Dudley College, and this one, you know, I've been teaching them astronomy for 6 weeks, and I said at the end of it, "So you really want to be an astronomer?" "No, I want to be a footballer." That's the end of that conversation. Well, hasn't it?
That beats being an influencer, isn't it?
An influencer, yeah. I didn't influence anybody, I don't think. By
influencer.
I probably talked about West Bromwich Albion.
I want to be a celeb.
Yeah. So that, yeah, we can organise that when we can get. Well, if you want to do one via Zoom, just let me know. We can set it up, and we can set a schedule up and a show, and you can do a show and then come in and chat about all sorts of things. It gives them a chance to learn about how to project themselves, you know, on air. They may want to go into media. They may want to be scientists. Whatever. We give them the opportunity. Dave?
Yeah. Can I ask Paul? In the schools, you're dealing with the elder school children. What was that? 12 to 16? Is it thereabout?
14 to 19. Yes.
14 to 19, even better, yeah. So in the schools these days, I mean, I've lost touch with what they teach in the schools. I'm still with the abacus and the slate. But astronomical science, what do they teach in the schools now? Because at one time it was on the curriculum, but just briefly in the physics section. So what do they actually teach astronomy now?
So astronomy is now its own GCSE.
Really?
Space physics comes into some specifications as a topic for GCSE, but astronomy is now a GCSE all on its own, which we have in the past run at our school, and I have run myself previously in previous incarnation, and to great success. And of course, there are other things. The A-level course, of course, goes into it as well, and we've got things like the British Astronomical and Astrophysics Olympiad competition, which the older students get interested in and like to enter to.
Sounds
very good. Yeah.
Have you noticed? Because we were going to quiz Andy tonight. He's vanished. He's disappeared.
Yeah. He'll be back. He can't resist talking, can he?
No. I tell you, when I'll say this on air as well. When when I've got the chat area on mute on the mixing desk here, when Andy starts talking, I can still hear the static coming through, and it's constant. And
that's just the noise that we hear in our heads as well.
I know it's Andy talking then. So when he comes back, we'll have to call him Mr. Static. So we'll do that.
We love Andy.
Andy,
Mr. Static.
Hello, Andy. How you doing, mate?
Hello. I'm on, am I?
Yeah, you're on. No, we were just saying
about you there.
Yeah, just chatting about you. I was just saying when I mute you lot in the chat, and you start doing some talking, you come through as static even though you're muted, and I can't work out how you do it.
It's a unique gift. I practiced for years to get that. I've just got an electric personality, Pete.
That's what it is. That's what it is.
Yeah.
Anyway, Andy, we've got 25 minutes now to quiz you.
Okay.
So I'm going to ask the first question.
Size 9 is the answer.
Tell us a joke.
Oh, tell me a joke.
One of your really, really bad jokes.
Well, this is a true story actually, and it's quite funny because I was having problems with the muscle in my arm, and I went to the doctor, and she said, without even examining me, she said, "Right, say ah," and I said, "Why?" She said, "Because my dog's died." Sorry, that was Sorry, that was just off the top of my head. You put me on the spot.
we must apologise to all the dog lovers in the world.
Yeah. Andy, back in the 70s, I went to a disco and I met a crab in there, and he said he pulled a muscle.
Oh.
Never mind.
If we're gonna go down that road,
no, we're not going down there.
We're down that road now.
Let's pull it back in.
Yeah, we'll pull it back in. I had to tell a joke today on Radio Shropshire because it was Red Nose Day or something. So
was it?
Oh. Yeah. Well, it's going to be. Now we've got to do jokes anyway. Andy.
Sorry. Yeah. Go on.
First of all, obviously you live in Spain. Yes. We know this. But where in the UK are you originally from?
Oh, I'm from the beautiful riverside place of Leigh-on-Sea in Essex, on the north bank of the Thames, near Southend.
Oh, that's beautiful there.
It is. It is absolutely beautiful. No, it is. I mean, Leigh-on-Sea is an old fishing village that hasn't changed much in about 300 years. And it's one of just a few villages in the country that still makes its living from sea fishing.
So is it really, really, really nice?
It's beautiful. Really.
Why did you leave and go and move in Spain?
Yeah.
Well, because I met my wife, and who's Spanish, and she lived with me in London for 3 years, and her mother became rather ill, and my wife was suffering because she wasn't with her. So I said, well, the only thing we can do is, to get you back with your family. Because, in Spain, the families are very strong.
Very close, yeah.
Yeah, very close.
The way families should be, yeah.
Absolutely.
Right.
And she was, she was coming off the phone from her mum every night crying. And I said, no, we have to go. We have to move there. So that's how we, I mean, I have to admit that I wasn't particularly averse to the idea of living in a place surrounded by forests and mountains with a summer that lasts for 6 months.
That's right. Yeah, I can imagine.
I'll do it. I'll suffer all of that.
It's a tough job, but someone's got to do it.
It was a struggle. Yeah. So, Andy, what inspired you first to start your journey in astronomy?
Well, I think I've mentioned on this program before. It was an Echo. It was the American Echo 2 satellite, which was an early telecommunications satellite. And we're talking about 1962 here. I would have been about 3 years old. And my father, who was into astronomy, bless him, he took me out in the garden and put me on his shoulders because it was quite low in the sky. So we had to see over the neighbour's fence. So I had to sit on his shoulders to see over the neighbour's fence. And I was only 3, but I have a distinct memory of this point of light crossing the sky. And of course, in those days, this was the early days of satellites. They were very rare. So this was like a big occasion. And I remember seeing that point of light crossing the sky. I don't remember much after that till I got to infant school. And they gave me a book to read called Moon, Sun and Stars. And I just got hooked immediately. And it went from there. And sorry, go on.
Yes. Did you ever think at that point in taking it up as a profession?
Yes, it was my first career choice, in fact. That was all I ever wanted to do. But my mother went and saw the careers advisor when I was in primary school. Because I think it must have been quite unusual because you wouldn't get that these days, a career advisor for children in primary school, but there was in those days. And they said, no, he can't do that because he's rubbish at maths. And it was true. And I had to have private tuition at home to get me through the maths part of my 11 plus, without which I would have failed because, we have a family weakness in maths. In fact, my niece Olivia, a couple of years ago, became the first person, a complete freak, ever to be good at maths. And she did a degree in physics at Exeter. So she's a bit of a strange one in our family because in living memory, there's
the black sheep of the Briggs family.
Absolutely. Well, no, distinctly white sheep. Very, very
white sheep. Yeah, well, it depends how you look at it.
And I have to tell you a funny story about that because my sister went down to Exeter to look around the place when they had their open day, and they take the parents off to do one tour and they take the prospective students off to do another tour. And when they get back together, my sister said to Olivia, you have to come to Exeter to do physics. You have to come here. And Olivia said, why? She said, well, they were taking us around and they were taking us past various laboratories. And they said, right, in this place, they're doing, electrical stuff, and this is where they're doing science, they're doing astronomical stuff. And we passed one door, and they said, and here's where they're researching invisibility. So she said, that is so cool, you have to come here. And Olivia said, that's good enough for me, invisibility, I'm into that. So she went to Exeter.
Well, nothing to see here then.
Yeah.
It was just a cupboard.
Just nothing in it.
Nothing in it.
One more question before I hand you over to the
to the vultures,
the illustrious crew. So, as you didn't do astronomy as a career, well, it was your career choice, but you didn't go down that road. What did you go down into? What did you go do?
It took me an extraordinarily long time to work out what I really wanted to do as a career, and I tried various things which didn't work out. But when I worked for Dixon's, those of you with long memories may remember that Dixon's used to have a terrible reputation for customer service. So they decided they were going to...
I remember well.
Yeah. They used to have a...
As you walked in the door, Andy, they pounce on you. Can I help you, sir?
Yeah, exactly.
No,
exactly.
thank you.
Yeah.
Yeah.
I used to manage the Dixon's Business Centre in Cardiff, which sold computers and software to mainly small businesses. Anyway, so they put everybody in the company, right from the managers of the stores, right down to the cleaners in the stores, anybody who worked in the stores, through a customer service program, which lasted 3 days. And mine was in a hotel in Watford. I thought I was staying there, but were Dixon's paying for me to stay there? No, I had to commute from Southend to Watford every day. Thank you very much. Yeah. And anyway, we had a company doing the customer service course called the Scandinavian Training Company, and I've tried to look them up since, and they seem to have sunk without trace. Not surprisingly, it was 1987-ish. And but the guy doing the training, a guy called Clive, was a brilliant trainer, and he was in front of a crowd. He was absolutely incredible. And I suddenly realized that was what I wanted to do for a living. So I went into training, into teaching IT, which I did for 30 odd years. And I adored every second of it.
Well, funny, Dixon's were the high street telescope shops back in the day.
And the camera shops.
And the camera shop, yeah.
And the hi-fi and everything else.
Yeah, because everything had Prince label on it, didn't it? It was the shin on. I got the shin on.
I've still got my telescope.
Was it the Prince? What
it
model?
Was a Prince.
Prince,
yeah.
Prince 330.
Was their own
I'll
brand.
get a picture of it all together.
In fact, please do, yeah.
Yeah.
But I used to go in there, go up at them, thinking, "Wow, these are fantastic."
One of the
good telescopes, optically wise. So yeah, I was going to say, optically, they were good telescopes. The mounts were a little bit dodgy, but the optics were fine.
Well, it's funny because Dixon's obviously sourced their stuff. Like Prince was their own brand name from reputable companies, and just slapped their badge on it.
That's it. Yeah,
one of their later brand names was Seisho. And I bought my mother a Seisho microwave. It was actually made by Hitachi, and this was about 1990, I guess, and it only died last year.
That's good going.
Yeah, it's not bad, is it? Not bad. Yeah. The only thing she ever had to replace in it was the bulb, the light.
I bet that's seen a few powdered paella.
I bet it certainly has.
A couple of Vesta meals in there, eh? Those crispy noodles were very, very crispy.
Yeah,
even with the soy sauce.
So I'm going to hand you over to the illustrious group who are going to now quiz you on some other aspects of your life.
Right, thank you.
Okay, so what would you like, Andy? Astronomical or non-astronomical question?
Anything. I'm prepared to answer anything.
Yeah, anything. Okay. Right. Do you recall your first view through a telescope of a star, planet, nebula, and a galaxy, or any of those objects? What was your first recollection of?
The first one I have a clear recollection of, Dave, was Jupiter. Because I had a 2-inch refractor. That I got from Scientific and Technical in Westcliff, which used to be a great shop. And I used to get up at sort of 4 or 5 in the morning to go and look at Jupiter. And I remember I must have been about, I don't know how old, 7 years old, 8 years old. And my parents thought they had a burglar because I was wandering about the house at 7 in the morning. And you know, and before school, or before my paper round, because I used to get up at 6 to do a paper round. So before the paper round, I used to go out and Jupiter's the first thing I remember seeing clearly through a telescope. And it was wonderful, of course.
What a memory as well. So just one other question before we pass it on. What was the first single and first album that you ever purchased?
No, that's easy. It was Hawkwind, Silver Machine.
Hey, same as myself. Hey.
Really?
Yeah, cool. What about album?
Well, immediately Hawkwind came out with Silver Machine. They released Do Re Mi Fa Sol La Ti Do.
Sound of Music then?
Yeah, absolutely.
that was Pete.
Yeah.
So I think about the Sound of Music.
Do Re Mi Fa Sol La Ti Do was the album they brought out just after Silver Machine, and that was my first album. Well, in fact, no, I sent my parents out to get Hawkwind, Do Re Mi Fa Sol La Ti Do, and they came back with the KTEL Top 20.
Right, see, it's very similar, isn't it?
Yeah. They said we couldn't find that one, so we got you this one. We hope you like it. And I said, take it back.
Take it back. I want my 12 and 6 back, please.
Absolutely.
Oh, was it 7 and 6 back in the day? Pre-decimal, of course.
I remember Silver Machine. Silver Machine was 48 pence when I bought it.
Decimalisation. Obviously, after the 15th of February, 1971.
Yeah,
there you go, decimalisation day.
48 pence, and the album was £2.50.
I'm just watching Peter on his camera.
Oh yes, and that was the next one I bought, the
Space Ritual.
Yeah. That is a best live album ever released by anybody.
Peter, is that Bubbles on the front cover?
Barney Bubbles. Stacia, meant to be Stacia.
No, Stacia. Stacia Bubbles. That was in the heyday.
Barney Bubbles was the lighting engineer.
Yeah, he killed himself in the end, didn't he?
Yeah.
Oh dear. Yeah. So let's open the questions. Roger, have you got any questions for our Andy?
About anything? I'll answer anything. I don't care.
Anything at all.
What's your PIN number?
Pass over from the now.
Andy,
okay. Let's
do you have a favourite Ealing comedy?
Why didn't you ask me that?
I love them all. God, let's think. The Lady Killers.
The Lady Killers,
which I absolutely adore.
Yeah,
it's fantastic. Those were the days. And I'm also very fond of Will Hay. I love Will Hay films
because he was an astronomer as well.
Yeah, he was. He was a
white spot.
The white spot on Saturn.
That's right.
Yeah. Andy, can I ask, what year did you graduate from the was it the College of Lifemanship with Terry Thomas? Because I think you must have been there with him, weren't you?
Yeah, about 1954. That would have been Simon. Yeah.
Okay.
Yes, good old Terry, good mate.
Yeah.
Never bought around, but he was a good mate.
Would you buy a telescope off this man? No. Do you have another question, Simon?
I suppose actually I was going to ask which sci-fi series would you bung into Room 101, but you may have answered that earlier.
Well, there's so many. If I'm pushed, I would have to go with Star Trek.
Which one?
All of them. Yeah.
Send all hate mail to Pete Williamson.
Yeah.
Well,
go on. Why?
Dig that hole deeper. Come on.
It's stupid. I mean,
that barbecue's not looking very interesting, is it?
Yeah.
Trekkie convention.
It's Republicans in space, isn't it? Basically, it's just the idea that you can become an alien by just putting a Cornish pasty on your head. I mean,
but they all speak English, which is pretty handy.
Yeah, they all speak English. They're all humanoid. Andy. They've all got American accents. I mean, it's just. I like hard sci-fi. I like sci-fi that talks of futures that could actually happen. I hate things like Star Trek that are so lazy and ill thought out and so cliched, and it's all American. You know how Americans reduce everything to sort of black and white? Well, it's a bit like that, and there's always a moral message in there somewhere. There's a bit of preaching in there somewhere, And I hate all that stuff. But the idea that, aliens will look anything like the aliens in Star Trek is patently laughable. So that's why I put it in Room 101.
You'd rather have like Doctor Who, where it's a carpet thrown over somebody. In fact, Star Trek did that. It was a carpet literally thrown over somebody, and it's supposed to be a silicon-based animal.
That's right.
And Spock communicated with it because it had a blister.
If there's one film that I think showed us what alien life could really be like, that is the film Alien.
Yes.
Because that showed us something that was alien, wasn't just somebody with a stupid costume. Well, it was somebody in a costume.
You know more.
Yeah.
I don't know.
When we get out into the universe, the idea that we're going to meet life forms that are so totally hostile to us and totally different from anything that you could ever experience.
I don't know. I've been to some clubs in Liverpool and I've met some strange aliens.
I've been to some in Cardiff as well. So
but then again, it came from outer space. You couldn't get any more than there's a jelly walking with an eye in the middle of it walking down the road.
And I was watching. That's a good film. I watched that again recently. Actually.
Well, what about Steve McQueen and the Blob?
Yeah, the Blob.
I've never seen
the Blob. I mean, it's worth watching because it's dead funny. But it's a blob. You know, it's just a load of jelly.
There was also one where they were
terrified of a jelly. You know?
Yeah, there was one where they were on an island and the aliens or whatever they were looked like fried eggs wandering around.
Of course, the jelly, you just get a big spoon with the fried eggs. You get a knife and fork, and a bit of salt and pepper. Just...
Anyway,
on to the serious questions.
Paul, any questions for him?
Anything at all?
Maybe talk kit.
Yeah.
Remember, what's your current setup, Andy, and what's next on your wish list?
That could be a touchy subject, but anything? He said.
Astronomical kit we're talking now, are we?
Yeah.
Not Airfix. Okay.
We might be better off actually making the Airfix kits at this point.
Other kits are available.
Level.
I've currently got an aging Meade ETX90 go-to telescope, which I bought when they were the first go-to telescopes to come out, and I bought it as soon as it came out, and it's just about dead. I mean, the computers died, and the finder scope keeps falling off, and it's due for replacement. Basically, I've never owned a really large telescope in my life, so I'm looking to buy a 200-inch next. So
Peter's got one or two that he might be flogging there.
Right. Well, we'll have to talk. No, just I fancy at least an 8-inch, and that is going to happen, I think, within the next year or so, because I live in this place. We do get a lot of clear nights. Not at the moment; it's been cloudy all this week. But I want to take advantage of this. And I've said this before on this program, Paul, but just for your benefit, when we moved here onto this urbanization outside this little Catalan village, we had no streetlights. And then they put them in. And when the council said we're going to do this, I said to my wife, you watch, with my luck, they'll put one just outside our house. And guess what they did? So because our garden is at the front of the house, we've got nothing at the back. It's all at the front. That ruined my observing from my garden because the street light is just too, just too overpowering. But then I can walk 2 minutes and be in the middle of the forest with totally dark skies, so it's not so bad. So I want to get a big scope that I can, perhaps lug up there on my back or something.
Can you not get onto the local authorities and get it shielded?
Oh, I tried that. No, they are shielded.
They are shielded.
It's the law in Catalonia. Catalonia's got very strict light pollution laws, and all the street lights are shielded. They have to direct their light downwards. They've all got hoods, but they direct them downwards right into my garden.
Right. So, What you need is a barbecue with astronomers coming over and maybe a black paintbrush, paint or whatever.
Well, I was thinking an air rifle would probably do better.
Well, you might be going a bit too far there.
Do you do any astrophotography? And if you do you use a star tracker?
No, I don't. Oh, sorry, I missed that. Very good. Yeah. Who's your friend?
Forget that one. You're not coming to the party.
I've done some astrophotography in the past, but nothing serious. And when I bought the Meade ETX90, I bought the camera adapter for it for my Olympus that I had at the time. And I've got some good results from that, but I don't have an Olympus anymore, and it was a film camera, and I've never really done any since.
Okay. So, do you play any musical instruments?
Yes, I do. I started learning piano when I was 6, I think, and learned the piano until I was about 15. And I used to have a baby grand. My parents bought a baby grand piano for me. That was also a pianola. So you put the paper rolls in and pump the pedals and it played itself. And they bought that for 50 quid, would you believe? And off an antique dealer who they knew. And then we moved from Leigh-on-Sea to Bristol, and there was no room in our new house for a baby grand, so we had to get rid of it. So I took up the guitar instead. I played guitar Well, I still play guitar, but I've been getting back into playing keyboards a lot the last couple of years. So they are. I write a lot of music. I write instrumental music of my own composition, and record it, and that's what I do.
Do you play with other people at all?
Not really. I used to when I was in Wales, because Wales is the land of song, of course. I was part of a huge group of musicians in Wales that would get together and form bands and then break up and form other bands. And I was always doing music with other people in Wales, but not since I moved to Spain, because, you know, it's a different culture, basically. And nobody understands the music that I do. So there we are, let alone like it. So
maybe it's an acquired taste.
Yeah, perhaps.
Yeah, well, in Spain they sing about their donkeys and that, don't they? So,
my donkey has left me, and
I've always said that.
Live in Essex.
Yeah. The classic Spanish joke translated into English is, "Did you hear about the donkey with 3 legs?" And that always gets a massive laugh in Spain.
Yeah,
so,
he always
and the first time I learned to tell a joke in Spanish, I was quite proud of myself when I was learning the language. And you know, when you can tell a joke in another language, I think you've cracked it, basically. And I told the famous duck joke, and it was tumbleweed. It was just the whole family, the whole of my wife's family just sat. I was so happy I was going to tell him this joke, and I'd learned how to say it in Spanish, and it was silence. And it wasn't because of the way I told it. I hadn't mistranslated it or anything. It just wasn't funny in Spanish. The Spanish just didn't find it funny, you know. And
I think I tried the same in German with a joke. And
yeah.
It was my dog has got no nose. How does it smell? Terrible. And I tried to translate it. Maybe Peter could actually do it for us. Meine Hund has keine Nase.
Meine Hund hast keine Nase.
Yeah. How does it smell? Go on.
I'm trying to think of smell.
Yeah, I can't remember. Wie smell it.
But on the other way around, my German friends tried to tell me a joke one night, and
let me just give you the punchline to that joke.
Oh, what is the punchline?
Yeah. How does it smell in German? Obviously, schlecht.
Schlecht.
Yeah, bad. Yeah, you know, schlecht. Bad.
The problem is the pun probably doesn't work.
Say again, Ron.
The pun probably doesn't work.
No, it doesn't. Well, the translation doesn't.
Well, it was the same.
Start.
The Germans, when I was out with my German friends, they were trying to tell me this joke, and it went in English. It went, this man was in his garden and he fell over and he tripped on a stone and he was eaten by the purple stone eater. And I go,
What?
No.
But
it's probably a play on words.
Yeah, in German, it was a play on words, and it was hilarious. And they were all rolling about laughing. And I sat there going, I don't think that translates too well.
Yeah, my dog has no nose went the same way.
Well, the next time we're all together, I'll tell you the famous duck joke anyway.
Please do. Obviously, it's not clean to put on
in Spanish.
No, it is. It's a perfectly clean joke. Yeah, I wouldn't have told it to my wife's family if that hadn't been clean.
Well, we got 30 seconds left to answer. Who wants to ask Andy the last question?
One quick question: Desert Island book. You can only take one book with you. What is that book?
Oh God!
And it can't be How to Survive on a Desert Island. So.
I think Frank Herbert's Dune.
How long is it? Is it a big book?
Yeah, it's about 300 pages odd.
Yeah, I remember watching the film. It seemed like a lifetime. So I can get that.
But you know, there's a new version coming out.
Yes, I believe so.
Eventually, had it not been for COVID, and it looks absolutely stunning. So do watch it. The David Lynch version suffered, there's so many do, from trying to condense a huge book into 2 hours. If they're given him 4 hours, he could have done something good, I think.
Well, thank you, Andy.
Thank you, guys. Thank you for your questions. They were great.
Andy.
Coming up on Reach Out and Touch Space next week, on Monday, we have Dr. Stuart Clark. Dr. Stuart Clark is an astronomer, lecturer, and also a musician as well, guitarist in a band. And he also writes and composes, like Andy, his own music. And he's also one of the organisers of Astrofest in London. So he'll be on Monday. And on Thursday, we have Stacey Downton coming on to chat about astrophotography and her life in astronomy.
Excellent.
So that'll be coming up next week. And in the pipeline, we've got Jeffrey Notkin, Meteorite Man. Alan Hale, we're hoping to have back. We might keep Alan Hale, though, till Solar Sphere Online, and he wants to do his top 100. So we'll just limit that down to top 10. Last time we had Alan Hale here on Astro Radio, I think, well, it was on Lock-In at the Locked-In, if you remember. And we got him on to talk about Hale Bob, because obviously he was one of the discoverers of Hale Bob, but he decided he wanted to talk more about how he'd met the group Hailstorm. And the link between him and Hailstorm, which he kind of was very tenuous, but he decided there was one. So that was Alan Hale, Hale Bob. So I've been talking to Catherine during the show tonight via email, and we've got a lot of interesting people coming up here on Reach Out and Touch Space. I want to thank you all for listening. As I say, we'll be back on Monday with Dr. Stuart Clark. Thank you to the panel. Thank you very much. Good night, panel.
Cheers. Thank you. Thank you very much, everyone.
And we're going to leave with Jolyn Turner and Two Lights. Or it could be Two Moons, I suppose. Two Moons Circling. Lovely bit from Star Trek, that.
It could have also been the episode where Picard is getting tortured. How many lights was it? Can you see 2 lights or 4 or 5 or whatever the hell?
3.